If I were to show you this image and ask you what it is, you'd probably instantly tell me that this is a dog. A question then becomes, how do humans actually do this? Well, we start with low-level patterns such as edges, textures, and colors within this image. Then we move to mid-level patterns such as shapes, such as pointed ears and round eyes for this dog. Then to more high-level patterns such as object parts such as the head and body. And then finally, a final detection of the whole object, and in this case, this means the dog. Then the question becomes, how do we actually get AI to do this? Well, the first thing we may think of is a feed-forward neural network. Here, the input image would be the dog, which is an 800 by 600 by 3 image. And we can get this into a matrix representation where each one of these values represents a pixel, and we have the same exact size as we had before. Then we can flatten this image, so we take each one of these rows, for example, and concatenate them together end by end, which gives us this thing. And the dimension of this just becomes 800 times 600 times 3, which gives us 1.44 million. And then we can finally feed this through a feed-forward neural network, which here has 1,000 neurons, 300, 64, 64, and 1. And this final output here gives us the probability that this input image is a dog. However, we get three problems with this. First is the computational explosion that happens here when we feed our flattened vector into this feed-forward neural network. Second is the loss of spatial structure as we actually convert this matrix into this flattened version, where once we take specific areas within this and flatten them out, we lose the spatial structure. So for example, these values, although they're together in the matrix, aren't necessarily going to be together here in this flattened version. And finally, we have no translation invariance, meaning that what we're learning isn't transferred once we change the image a little bit. So for example, if we flip this dog over horizontally or vertically, what our neural network is doing is learning these values exactly and saying once this matrix is these values specifically that we have a dog, which is not very useful when we're trying to learn the general cases. And we'll talk more about each one of these three in the next video. And if you'd like to learn more about CNNs and go into more detail about these three and how CNNs fix all of these, please check us out on YouTube.